All right, guys. So now we are looking at part two of the last section, 8.8, where we are factoring cubic expressions. And the first type we did here was where there was no constant term, and here there is a constant term. So the four examples are going to have constant term. Now, how are we going to do this? We are going to use a skill that we know already. So these are four terms. So n to the third, second, the first, and then it's a constant. Now, if you notice, these numbers over here are have a pattern, right? And we are going to see if grouping them like this, like how we did earlier for quadratics, helps. Well, let's try that. So 3n to the third minus 12n squared. So let's think of the greatest common factor. So 3 and 12 is going to be 3. N cubed and n squared would be n squared. And that gives you n minus 4. All right, so I hope you're understanding, and it reminds you of what we did earlier. Okay, plus 2 and 8. So the only common factor is 2, and therefore there's no other variable. So when you factor out a 2, you'll end up getting n minus 4. There you go. Does this remind you of that previous section? So now do you see n minus 4 and n minus 4 are the same? So what do you think we are going to do? Absolutely. So factor that out. So n minus 4 can be factored out. So think this guy is gone. You're left with 3n squared plus, so if this guy is gone, you're left with 2. So that's it. I have now factored a cubic expression by grouping. So what did I do? I grouped this into two. So group and then pick out the GCF and then rewrite the factors. So write the factors. So it's pretty easy if you think about the steps. Now let's look at the next example. So if you have not understood that yet, pause, go back, check again, all right? So now look over here. So I have 24, so I'm going to group them, and remember the sign always comes along, all right? So 24 and 42. So don't be tempted to say 24. No, 24 is not the common factor. So you know 2 goes into it. How about 3? Yes. How about 4? No. 5? No. 6. So which one is the greatest common factor? Obviously, it's going to be 6. So don't be tempted to pick these two, like 2 or 3. We are talking about the greatest. So pick 6. And t to the third and t squared, it's going to be, yes, t squared. So therefore, the GCF is 6t squared times, not, well, parentheses, 4t minus 6 times 7 is 42. Make sense? Now, over here, 28 and 49. Oh, are we going to have any number like that? So that is 28 and 49. That's going to be 7, I think. I want to say 7. So minus 7 times, this will be 4t, right? Then since you have factored out a 7, a negative 7, there's going to be 4t minus 7. Okay, so therefore you have grouped them, and now if you look at it, these two binomials are the same, 4t minus 7. So that's going to give you 4, let me factor that out, times 6t squared minus 7. So if you factor out the 4t minus 7, you're left with 6t, and then 6t squared minus 7. And that is the factored form. Okay? Hope it makes sense. Now, let's go. The last two. So same concept. You can try it yourself and then play the video to see if you're right or not. Okay? So look at that. If you did this group, I like that. Now 9 and 12, the greatest common factor would be 3. A cubed and a squared, it's going to be a squared. So that you're left with 3a minus 4, right? There you go. Plus 18 and 24, yes, 6 is the greatest common factor. So you're left with 3a minus 4. And now you see these two are the same, so it's back to the same step. So 3a minus 4 can be factored out. And you're left with 3a squared plus 6. All right? So now if you think about it, and if you're going to factor out, you will end up, if you distribute it, you should end up getting the same answer, right? So 3a times 3a squared, and then 18a minus 4 times 3 would give you that. And then now if you're, so this is good, right? But do you notice something over here? 3 and 6, I'm tempted to factor out a 3 there. So you can go that extra step. So 3a minus 4, so that can stay. Now 3 can be factored out. That will give me a squared plus 2. Look at that. And now I should rewrite it in a nice way. So 3 times 3a minus 4 times a squared plus 2. Now, is this step necessary? Yes, you do have to do it because we love math, right? So don't leave it like that. Try to go over. So many standardized tests will give you answers like that, and you should know how to do it. Okay. Well, now the last problem of this whole entire unit. Let's go. So 6y to the third minus 3y squared. Again, 6 and 3, the greatest common factor would be 3y squared. Leaves me with 2y minus 1 plus 2y and 1. I don't have any common factor except, yes, 1. So 2y minus 1. So therefore, look at that. So this is an example where you need to put that 1. Sometimes we say, hey, it's just 1. Why should I write it? So here, if we don't, then it'll end up in a mess. So let's go. We have 2y minus 1, the same binomial. So factor that out. And you are left with 3y squared plus 1. All right, so here there's nothing more to factor, and you've factored all of it. Okay, so if you think about these, the 4 problems are very nice and simple. You don't have to stress, but the prereq is, do you know how to find the GCF? In all these problems, that's the prereq. If you don't know that, then yes, you might have a hard time, all right? But I hope this entire section is clear to you. If not, let me know. Thank you very much.